Hello students, welcome to the mathematics class. In this class, we will discuss some statements for the factors and multiples. The class is 5th standard. First, what is the factor? The factor means it is the divisor that exactly divides the given number. What is that? The factor is a divisor that exactly divides the given number. For example, 2 into 3 is equal to 6. The 2 into 3 is equal to 6. There, 6 is the product of these two factors. The 6 is the product of these two factors. So, what is the factor? It is exactly divides the given number. So, the 6 is divisible by 2 as well as 3 there. So, the 2 and 3, these are the factors of the 6. Okay, the next one, the multiples. Yes, what is the multiples? Multiples are the product of two numbers. These are the product of the two numbers. Yes, take the same example there. The 2 into 6, 2 into 3 is equal to 6. The 2 into 3, these two are the factors. The 6 is the product there. The multiples are the product of two numbers. Yes, what is the multiple there? The multiples are the product of two numbers. The 2 into 3 is equal to 6. When 2 is multiplied with 1, 2, 3, 4, 5 so on, we obtain a table of 2 there. The product of 2, 4, 6, 8, 10 so on. These are the multiples of the 2 there. For example, so 1 into 2 is equal to 2 and the 2 into 2 is equal to 4 there. 2 into 3 is equal to 6. These are the tables of the 2 and these are the multiples of the 2 there. These are the multiples of the 2. So, what is the multiple there? The multiples are the product of two numbers. Next one, what is the prime number and the composite number there? The first we have to discuss about the prime number. Yes, what is the prime number? It is also a number that has only two factors there. It has the only two factors, 1 and number itself. The 1 and number itself. For example, the 3 has the only two factors there. The 3 is divisible by 1 and 3. And one more example, the 11 also divisible by the 1 and 11. So one more example, 23. The 23 also only two factors there, 1 and 23. It means the 1 and the number itself. So 1 and 23. So 3, 11 and 23. These three examples are for the prime numbers. What is the prime number there? It is a number that has only two factors, so the 1 and number itself. Okay, next one, the composite number. The composite number means it is a number that has more than two factors. It has the more than two factors. For example, the 9, it has the factor 1 there, and then it is divisible by the 3 also, and it is divisible by the 9. So now it's clear. The composite number means it has more than two factors. What is the prime number there? It has only two factors, 1 and itself. But the composite number, it has the more than two factors. So one more example, the 27. The 27 is divisible by the 1 and it is divisible by the 3. Then it is divisible by the 9 and it is divisible by the 27. That means it has the more than the two factors here. So the 9 and 27, these two are example for the composite numbers. Okay, next let us discuss about the some rules for the divisibility. Okay, next the test of divisibility. The divisible by these numbers, the 2, 3, 4, 5, 6, 9 and 10. There are the sum rules for these numbers. And what are the rules? So, we have to derive some examples related to these rules. Okay, let us start one by one. Yes, already we know that what is the prime numbers and composite numbers and what are the factors there and what are the multiples. The first rule is the 2 divisible by the 2 digit in the ones place is 2, 4, 6, 8 or 0. Yes, these numbers are divisible by the 2 there. Okay. Next, the for example, the 44. Yes, the 44. In a ones place there is a 4. So, the whole number that is 44 is divisible by the 2. Why? Because the rules says that it declares that here in a ones place there is a 2, 4, 6, 8 or 0. The whole number is divisible by the 2 there. Okay. Next, the one more example for the divisible by 2, that is the 256. In a ones place there is a 6. So the 256 is divisible by the 2 there. Next, one more example. The 8910. In a ones place the 0 there. So the whole number 8910. That is divisible by the 2. Okay, next go to the second rule, that is divisible by the 3. The sum of all the digits is divisible by 3. Yes, the sum of all the digits is divisible by 3. That means, for example, the 165. Yes, we have to check the 165. It is divisible by 3 or not. So, what is the rule there? The sum of all the digits. So, add all the digits there. So, 1 plus 6 plus 5. That means the 1 plus 6 plus 5. That means the 12. What is that? The 12 there. So, the 12 it is divisible by the 3. So, the 165 is divisible by the 3 there. So, one more example for that. The 590. The 590. So, 5 plus 1 plus 9. That means 15. The 15 is divisible by the 3 there. So, the divisible by 3 rule is applied for 519 as well as 165. Okay, next go to the third rule there. The fourth divisible by the 4. The last two digits are 0 or divisible by the 4. That means, I will give the one example. The 408 there. The 408 is what is the rule? The last two digits are 0 or the divisible by 4. That means 0 and 6. These two are the last digits there. So the 8 is divisible by the 4. So the 408, the whole number, the 408 is divisible by the 4 there. Yes. Next, one more example. The 2440. Okay, check the number there. The two digits or the one digit is the 0. Otherwise, the two digit, the 40 is divisible by the 4. The 4 tens are 40. That means the 2440 is divisible by the 4 there. Yes. Next, the divisible by the 5. Digit at ones place is 5 or 0. Digit at ones place is 5 or 0. That means, for example, the 50, the 45, the 790. Yes, there are the three examples there. The 15. Let us discuss the first one. The 15. 15 means the ones place the 5 there. So the 5 is divisible by the 5. So the 15 is divisible by the 5 there. Next, the 45 there. The one more example, that is 45. In a ones place there is a 5. So the whole number, the 45 is divisible by the 5. The 790, this is the third example. The 790, in a ones place there is a 0 there. So the 790, the whole number, that is the 790 is divisible by the 5. Why? Because what the rule says here, the digit at ones place is 5 or 0. So the 15, 45 and 790, these numbers are divisible by the 5 there. The next, the divisible by the 6, a number that is divisible by the 2 and 3. So we have to apply the second rule as well as the third rule here. For example, the 432, is apply the second rule there. What is the rule 2 there? The digit in the ones place, there is a 2, 4, 6, 8 or 0. Check in a 432, the 2. In a ones place there is a 2. So the 432 is divisible by the 2 there. So one more rule there, that is 3. The 3, the sum of all the digits is divisible by the 3. Okay, let us check. That is 4 plus 3 plus 2. That means that is the 9. The sum of all the digits, we get the 9 there. So 9 is divisible by the 3. So both the divisible rules applied there, the 2 as well as the 3. So the 432 is divisible by the 6. Okay, next, the 9th, the divisible by the 9. The sum of the digits is divisible by the 9. So for example, the 18 and 54 there and 162. So 1770. Yes, we will check the 4 examples one by one. What is the rule there? 9 1. The sum of the digits is divisible by the 9. So 1 plus 8, that is 9. So 1 plus 8, that is 9. So the 9 is divisible by the 9. Next, 54. 5 plus 4 there. The 5 plus 4 is 9 again. The 9 is divisible by the 9. 9 ones are 9 there. So next, 162. The 1 plus 6 plus 2. We get the 9 there. So again, the 162 is divisible by the 9. 1770. That is, add the number there. 1 plus 7 is equal to 8. The 8 plus 7 is equal to 8 plus 7 is equal to 15. The 770. 1000. So 170 then. So 1 plus 1 is equal to 2. 2 plus 7 is equal to 9. So the addition of all the numbers, we get the 9. So 9 is divisible by the ninth rule. Okay. So apply the ninth rule. What is the ninth rule there? The sum of the digits is divisible by the 9. The 18 is divisible by the 9. And 54 is divisible by the 9. Then 162 is divisible by the 9. 1170 is also divisible by the 9. Yes, I hope the 9th rule is clear here. What about the 10th rule then? The divisible by the 10. The digit at the ones place is 0. The digit at the ones place is 0. For example, the 470 and then 1580 is in the ones place. There is a 0. So the whole number is, look here, the 470 and 1580 in a ones place. There is a 0 there. So the 470 and 1580, these two numbers are divisible by the 0. Yes, we understood what are the rules for the divisible by 2, 3, 4, 5, 6, 9 and 10. So we clear the examples also. So for this knowledge, we will move to the exercise. Yes, recall the rules there. The divisible by the 2, the digit in the ones place, that is 2, 4, 6, 8 or 0. For example, 44, 256 and 8910. In a ones place, there is a 4, 6 and 0 there. So all the three numbers are divisible by the 2. The third rule, the sum of all the digits is divisible by the 3. So for example, 165. So 1 plus 6 plus 5, we get the 12 there. The 12 is divisible by the 3. As well as one more example, the 590. So 5 plus 1 plus 9, we get the 15. The 15 also divisible by the 3 there. Okay, next, the fourth rule, the last two digits are 0 or divisible by the 4. For example, the 408, the last digit is divisible by the 4. And 2440, the last two digit, the 40, that is divisible by the 4. So apply the fourth rule. Next, fifth one, the divisible by the 5, digit at ones place is 5 or 0 there. The 15, 45 and 790, that means in ones place there is a 5, 5 and 0 there. So all the three numbers are divisible by the 5. Next one, the divisible by the 6, a number that is divisible by 2 as well as 3. It means the 2 and 3. The 432, the last digit is 2 there. So the second rule is applied for the 4432, and so we have to apply the third rule also. Yes, what is the third rule there? The sum of all digits, the 4 plus 3 plus 2, we get the 9. So the 9 is also divisible by the 3 there. So the 432 is divisible by 6. The ninth rule, the sum of the digit is divisible by 9. The ninth rule and the third rule, both are same here. The 80, 54, 162, 1170. Yes, apply the ninth rule there. The sum of the digit, that means the 1 plus 8 is equal to 9. So 5 plus 4 is equal to 9. So 1 plus 6 plus 2 is equal to 9. So 1 plus 7 plus 0 is equal to 9. All the numbers are divisible by the 9. Next, the last, that is divisible by the 10. The digit at the ones place is 0. The 470, 1580. Look here, in a ones place there is a 0 there. So these two numbers are divisible by the 10. Finally, the one more rule there, that is divisible by the 11. Yes, before the exercise, the one more rule there, that is divisible by the 11. If the difference between the sum of the digits at odd places and sum of the digits at even places is either 0 or divisible by the 11. For example, the 26,378 there. So already you know that what are the even places and odd places. The 2, 3 and 8, these three digits in the odd places. So write the 2 plus 3 plus 8. These three digits in the odd places. The remaining, yes, write the subtraction there. Why? Because in the rule there is a difference between So the remaining numbers, the 6 and 7, these two digits in the even places. So the 6 plus 7, the sum of the odd places and the sum of even places. That means the 2 plus 3 is 5, the 5 plus 8 is 13, minus the 6 plus 7 is 13. So 13 minus 13 is 0 there. Yes, either 0 or divisible by the 11. So there is the difference between odd numbers and even numbers. The odd digits and even digits there. That is 0. So one more time, the sum of the digits at odd places and the sum of digits at even places, that is the difference between these two digits there. The 13 minus 13 is equal to 0. So